Ladies and gentlemen, welcome to RPI Data Science. Today, I would like to show you how to plot regression models. So, you're running a regression model depending on your model of choice. Maybe you're running a linear regression model, or maybe logistic regression model, or any advanced regression models. So you want to, once you run your regression model, you get the coefficients or maybe odds ratios or any kind of estimates that you get from your regression model. So once you run these models, you may want to plot them in a forest plot instead of putting them in tables. Because figures is words more than 1,000 words, and it's more elegant than presenting them in tables. So it might be worth looking at presenting regression models in forest plots. So today, that's my goal. That's what I would like to show you. Perhaps if my video is slow or fast, you may want to reduce the speed or maybe increase the speed. Let's say if you are watching one of these videos, so make sure that you hit the subscribe button so that you can you can encourage me to make more videos. At the same time, you can also follow what's happening in this channel. Or every time I add a video, if you hit subscribe, you will be notified and you can watch them. So let's say if you are running, if you are watching one of these videos, and if the speed, the way I speak, if it is not fast or if it is too slow, so you can hit this setting button and then you can increase the speed. So it might be, I always use this button depending on the speed of the presenter. So you may want to make it like if I'm too slow, then you may want to do it into 1.5 or 1.75 or even more. So that's what I would advise. So I don't need this window, so I will close it. And instead open in my Jupyter notebook, I will open a new SOS notebook. So once I open this SOS notebook, the good thing with SOS notebook, as I said in my previous tutorials, is you can run multiple kernels, multiple programming languages. You just need to choose the programming language of your choice, and you can run multiple kernels in just one notebook. So now the data that I will be using is from the life expectancy data. I think this data is from the Global Health Observatory. You may find it online, and it collects data from 193 WHO member states, and it has many variables in the country. So for this purpose, let me load some libraries that I may need. So one is, let's say I may need Gplot. But the other ones, maybe I will load them as we go along the way. So let's say I also need Gplot too. Then the next thing I would need is to read the data. Let me change this kernel to R, and then let me read my data. So let me call it life expectancy. So I don't need any other package. So let me call this life expectancy, and let me read the data. To read the data, it's a CSV file. So let me call read CSV function, and then let me write life expectancy. So it's a Jupyter notebook. It's already detecting my hinterland. It might be worth looking at my previous tutorial on auto-completion. So this auto-completion is very helpful. So it gives me it helped me to complete the rest of the code. I just need to type some of it, and then the rest of it will be completed by the auto-completion option of the Jupyter notebook. So now I just need to add some more lines. So let me read this data. So once you read this data, let's say it's already read. So once I read that, let me see the head of this data. So let me show you. This is how it looks like. So you have many countries and the year and then developing, whether the countries are developing or developed countries, and you have life expectancy, and all this bunch of variables. So what we're gonna do is I want to first, let me look at the names of the columns. That means the variable names, because some of them they are written in a way that R may not like, and it's preferable to choose to change these variable names into in a way that are likes. I think this doesn't look nice. I mean, there are capitalization, there is this full stop sign, and in some way, in some of them, there might be space or something. So I need to make it more easy for R. So let me see my variable names for this. Maybe I think I made a mistake here, so I don't need this E. So let me read this. So this is how it looks like. It's a little bit boring, so I just need to standardize this variable name. And the great thing with, I mean, you can write your package by string, string manipulation, like you can replace. You can change all these to lore if you know string add function, but I'm not going to present that. I will go to the easiest way because there is already a written package for us. We just need to use that, and that's from Jupyter package. They have also other important functions, but for this purpose, I will just use the clean names package. I mean clean names function. So let me just say, let me call it life expectancy. Now life expectancy, and let me add data because this is already new data now, and then I will just change it into clean names. Let me call this clean names function from Jupyter package, and I will use this one. So let me call my already existing data that I already read. And now once I have that, let me have a look at the names, how the variable names are written. So you can also use the column names or other function to just display all your variables. So now if I run this, so this is how it looks like. So now the variable names are more elegant. So if you see, these are the capitalization, and so it's really one nice function that every data scientist need to know. I mean, you might write your own function. It's just you can use a string R, and then you can connect it with to lore. String to lore, or and then you can let's say if there is a full stop, you can replace that with hyphen. It's kind of easy. You can also check how this actually written. You can also manipulate this. Let's say if we can use this, and probably Jupyter Notebook doesn't work, but in okay. Yeah, let's forget this. But I will come back to another session, how to write, how to how to edit the already written function, and then make your own function. Let's say if the function is to avoid duplicates or something, and then you may want to keep the duplicates instead. So you can, the good thing with R is all the functions, they are open access, so you can change the function into your own need. That's a great advantage of this open access software R. So now I have all my variable names. They are in standardized. So let me have a look at the data. So you can also, because I already have Gplot loaded, I can have a look at how the data looks like. Yeah. So it will come. Five observations are going to be displayed. No, actually not 5 observations. This is not the head. This is rather the glimpse. It's not the structure. I mean, it's like if you can also use this structure. So I mean, it's a more elegant way of looking at this the type of your data and how it looks like. So if you see the country, I have the year status. whether the country is developing or not, or developed, and the life expectancy information, and so on and so forth. There are so many other variables. So let me add now. Once I have seen that, so these are the type of variables. So you see this. Then the next thing is to have a look at whether there are missing data or something. So you can, for that, what you can do is you can load a library called Data Explorer. There are also other packages where you can visualize missing data. So once I have that library, Data Explorer, and let me load this. It might take a little while, but it's already loaded. It's great. Now the next thing we can do is we need to view the missing data. We want to plot them in the kind of a nice bar chart. It plots the missing and the percentage of missing data. So it might be a very useful function, but there are also other packages for visualizing missing data. So now you see this is elegantly presenting the missing data. So you see in this case there are no missing values. So I mean in the first one, because it's showing 0% of missing values, but in the next ones it's showing like 0.34. Yeah, those kind of things. So if your data has a missing value more than 15%, at least for these variables like GDP, hepatitis B, or population, it might be difficult for your model. Let's say if you want to impute them, probably I wouldn't consider imputing a variable which is more than 20% of it is missing. So instead you may do complete deletion. You may want to delete the variable out of your model, but there are other many ways of imputing data instead of using these dirty methods of mean or mode imputation and the like, or median imputation. These are pretty dirty methods of imputation, but you can try to impute data for missing values if the missing is tolerable. Let's say if it is less than 15%, I think it's tolerable depending on the number of observations you have. So that means you can impute data. So for that imputation, I will come back with another video for imputation techniques. There are many ways of imputing data. Especially if you look at the recipe package. I really advise this package, the recipe package. So they have many ways of imputing data, and the other package that you need is this mice package, multiple imputation technique using chain equation. Yeah, I will make another video in the future with how you can impute using KNN, this K nearest neighbor, or as I said, mice using multiple imputation chain equation, or the other one like a random forest. These are really a very good way of very good techniques or methodologies that could be very important if you would like to impute missing data. I will make another video. Just keep in touch. So now we have our missing data. So the next thing we need to do is to try, let's say we do complete deletion. So we can remove all rows with missing data. I mean, this is just for tutorial purpose, so I don't need to use any observation that has missing data. So I will just delete all rows with missing data. So I just need to delete them. But practically, and that may not be needed in your data. If you have missing value, you may need to impute them depending on the missing percentage that you have. So to do that, to delete my so what I do is life expectancy NARM. So let's say no missing value or missing values are removed. So let me type this life expectancy data the one which I already pre-selected before, and now I can use these complete cases. Then I can run this. So once I have that, I would just bring the other one, so this one here. Life expectancy, complete case, things like that. So if you simply run, let's say, then because I'm interested in the rows, I will just keep this at the back. So if you run this, let's say, if you simply run this, I think if you run this one until here, what you would get is whether the data, the observation has missing value or not. You just find whether an observation, let's say in the first observation it doesn't have any missing value, but in some of the other observations they have missing value. So if you again connect it with this, so that means it will select only observations that have no missing value. So let me do this, and then let me count how many rows that I have. Row sum, let's say, how many rows or how many observations do I have, and then life expectancy, let's say NARM, MC, okay, group is missing. Now I can also see dim, actually dimension. That's actually easier. So I can just visualize the number of, so I have 1,649 observations and 22 variables. So let me add a few more code cells. Then once I have that, let me have a quick look of histogram, plot histogram like this, and life expectancy in a array. That's what I have. So this one will take a little bit of time and then it's displayed. So this is how it looks like. So you see how some of the variables are not are skewed. Let's say in this case it's positively skewed, and in this case it's kind of negatively skewed. Some of them really don't look like normally distributed. And, probably this one is okay, but otherwise most of the variables are not really normally distributed. So I'm not again going into the details of this distribution, whether a model is relevant or not, because my goal is just to show you how to plot regression models in a forest plot. So that's just my goal. So I will just simply proceed with my modeling. So let me check. Let's say the next thing that we need is modeling. But before modeling, we may have to look at some of the how the data are distributed. I mean, like a not distribution, how one variable, like a scatter plot, how one variable is related to each other. Just before that, you remember we have this plot, but you may also want to look at the previous presentation that I had in my YouTube video. You may want to look at my channel again, and I did some I think some nice pair plot. So you see there is this pair plot matrix. So you may want to apply also these methods. I added some way of doing this pair plot, how one variable is related to each other, I mean to the other, and then you create this sort of matrix. This is just only a matrix of histograms, but you can also have a matrix of relationship between all variables to each other. Yeah, that's one thing. So the next thing that I want to do is I need to give you I need to change actually some of my variable names. Let's say names. This is what I need to do. I don't type it. So let's say names, life expectancy. This is my data, and then names again. Now I will do it into income composition of resources, and now I will rename it into income index. So let me run this. Now it's already done. And then the next thing is I will need to do Gplot to visualizing like a quick scatter plot. So let me write the data. So that's the formula that you have to follow. And then x, the x variable, my x variable is income index, the one I just mentioned, that I just written here. So let me call this here, and y equals life expectancy. That's my dependent variable. Life expectancy. So it's a little bit different from the way I save my data, but it might be better to save your data into the right name, which actually doesn't compete with your variable names. So for me, it's I did something wrong here, so I didn't name my data with a name that doesn't compete with my yeah. The next thing is I need to add the plotting function, that's geom_point. So this is now I can run this, and I can have a look at some relationships. So you see, when you look at this, so if you see the income index, as income increases, obviously life expectancy increases, and that's also the same for developed countries and for developing countries. But there is something weird here. So you see a lot of zero values having all of this. So these are missing data, I would say. So missing data might be coded as NA or 0. So there is no data or something. So probably this is something that you have to deal with. Let's say we may have a look. Summary of the life expectancy. It's a life let me call my data here, life expectancy in ARM, and then income index. Now, oh, no, I made a mistake. Okay, income index. So if you look at this, so you see the income index, there are 0. So many observations have 0 values. So you have to remove these cases. So you have to let me count them. Let's say how many cases actually have 0 value. So let me count them. Life expectancy, income index is 0. So if I count them, I have 48 observations with this value. So all of these points, they are 48 observations, and they have an income index value of 0. So you have to find a way to remove these observations, otherwise they don't look great. Yeah. So now the way, how am I going to remove them? So the easiest way would be using dplyr, that you can filter them out. So let me do life expectancy. Let me call this life expectancy new data, and let me save it. Let me call my previous data, the one I have, and let me pipe it with this pipe operator, and then filter. Let me use filter, and then income index is greater than 0, or maybe you may use it's different from 0, but I just need to there is no negative income, as you have seen, so all of them are either 0 or more than the mean was this one. So I mean, not really this one, but it's like 0.28 or something like that. I don't know how this so this every 0.25, so this should be around 0.27 or 8 or something like that. So this is how we will filter them out. Now let me bring this code again and just change the data. The rest would be the same. Now let me call this and yeah, run this. Now it looks nice. So you see, let's say if I add some geom smooth function so that I can run, I can have like a line plot so that it's just to show the regression line. So to make that, I can add this geom smooth function, geom smooth, and let me add method. What kind of method? Let me use LM, linear model. You can change it depending on your model of choice, or you can also write your own model and then you can change this function and add your own model. So let me give it a color blue color, and then let me run it. Yeah, so it's using LM, linear model function, and it's showing you can change the size of this figure or type of this. Let's say you may want to put it in dashed line or something, but I don't want to go through to that. You can have a look the details of geom smooth function, but it's not very. I mean, it's not very difficult. Now the next thing that I need to do is I need to do linear model. Let me write a linear model or simple linear regression model. To do that, let me have what I can. Let me call this model as LM1, and let me write LM. That's my y variable is life expectancy. So life expectancy as a function of is tilde sign. So it's as a function of what, for example, total expenditure. Might be a good idea. So if I write the data, maybe it will be detecting my variable names. So maybe I can just use, because I already use this from my blog page. You can all find all of this from my blog, which I will reference later on. And if you see these variables, let me create more lines so that it will be more readable. And let me put this down here. So now I just added a bunch of variables. So life expectancy as a function of the total expenditure, and then I put this in log scale, and then I do, say, if you do hist income index, let's have a look how income index looks like, and let me call my life expectancy data, and then here okay, life expectancy is actually the variable, not the data. So let me call this one rather. So now you see it's kind of normally distributed. I mean, you can have a look, you can check like a normal distribution testers like Shapiro, Wilk test, and the like, and you can check. So that if I actually transform it into to logarithm function, it's actually getting worse. So probably it might be a good idea to keep it as it is. So let me put it as it is. So, but you need to investigate your variables, how they are distributed and the like. So sometimes you may have to change them into log scale or transform them in square root or box transfer. There are many transformation techniques that you can try. So now I just completed my model, and I can check summary of my model. Let's say summary LM1, then this is not what I want, so LM1, so it will take a little bit and then it will display. So this is how my model looks like. So you can have your intercept. So you have your estimates, beta coefficients from intercept until the last variable, all of them. And then you have all these significant, whether the variable is significant or not. You have your standard error, for example. I have a big coefficient here, and then yeah, still the standard error is very high. Yeah, so things like that. So maybe might be a good idea to log it so that it will get better in my estimate. Yeah, still high, but probably it's okay. And the next thing that I need to do is I would like to get a nice, instead of this kind of table, you might want to look at a nice looking table. So maybe you want the JTools package. The JTools, it's a nice package to have an elegant table. So I can load this package, and then once you load this, JTools package has this sum function, which will be which you can call your model. And let's say if you want a confidence, so if you want a confidence intervals, you can make this true. You can just type t, for example, or I mean it works if you just type t. And you can also write the digits, the number of digits. I mean in this case you see it's a very long digit, so but you can reduce this, let's say, into 3 significant digits. And if you want the variance inflation factors, because this is very important, these VIF values are really important to check whether there is any multicollinearity or something. So you can, this is really helpful, so that it helps you to identify the multicollinearity between variables. Then you can VIF as assign as VIF as true. So that's what you need. So once you have that, you run it, and you will get a nice looking table. So you have this kind of table. It looks very nice. You can also copy this and put it in your Word file, and it will appear as so if you are using HTML, you can just copy this and use it. You just want to, I don't know, maybe edit some of your variables. Otherwise, this looks nice. And our R² value is also high. But looking at these values, so the variance inflation factor values. So you see this variable has a high value, so that's like 6 point something. So that means what you need is you need to remove some of these variables. So let's say what you can do, because it's these variables have you know, the variance inflation factor value above 2 means it's there is an evidence of multicollinearity in your model. So that means you need to find out whether to avoid to remove this variable, or yeah, what can you do? Let's say in this case, let me do something. So let me do some filtering. Let me filter some of the data. So let me call this as DAP, and let me bring my data and then select some of these variables, the variables which are already here. So once I have that, and then let me do correlation. Let's say core, let's say from HMISC, I think, or you can also do like core, maybe not a Gplot library, Gplot. Let's say I was also showing this in my previous in one of my previous tutorials. So you can what you can do is like you can do correlation, R-core, and then let's make it matrix. Then you can call your data. For that, I think I need the hmisc. I don't know how you read it actually. Hmisc. Let me call my hmisc function library and hmisc. Once I have that, and then let me see the correlation values, because this is showing me there is evidence of multicollinearity. So it looks like I made somewhere an error. So core okay, sorry, I need to do this core or the correlation values, and that's R. So let me do this. If I run this, what would happen? Okay, so there seems something is wrong. Core R, let me put it as table, let's say, and let me call R again, this correlation values. Okay, so it seems I make a mistake, so let's say it's complaining. Library. Okay, core plot. Once I have the core plot function, then I have this hmisc. Maybe they are competing each other, you know, this hmisc and core plot. Hold on. Okay. Oh my god. Okay, so this is where I made the error. So let's say I think I can just simply use core plot instead of using oh yeah. So let me create a correlation matrix for the whole data set. Then once I have that, I can plot the I can plot them. So to do that, I think what I need is I need to create the core function, and then my data, then I give it the method. So let me give it Pearson, and maybe let me give it a name, correlation matrix. So let's do this, and then once you have that, I think it should be possible even to have an elegant kind of plotting. So once that means first I need to create the correlation. Let me put this and run this. So once I have that, let me copy this and put it in a new cell. So what if I do this, if we run it, so I will have this kind of plot, but you can change it. I mean, this is your choice. Let's say if I do method shade, then look like this. So, but I can also show the values. To show the values, I think what you need is add color true, add coefficient color. So I put it this and then run. So it looks something like this. So having, if you look at these variables, so let's say in this case, this variable thinness, thinness 1 to 19 to thinness into 5 to 9 years. they are really highly correlated. And another variable like schooling and income index, they are also highly correlated. So you need to deal with these variables. So that maybe it might be a good idea to remove them. Yeah, find out what you can do with. So there is a high correlation between thinness and thinness 5 to 9 years. And then if you have a look, schooling also with income index, that's also a high correlation. So to deal with this correlation multicollinearity problem, what you can do is you can just drop one of the variables. Drop one of the variables because they just add, what they add is they will add redundant information. So you are adding the same kind of information more than twice, I mean more than once. So in that case, you can drop one of the variables and then do your model. So that means what we can, I need to drop thinness 5 to 9 years and then keep the other variable thinness 1 to 19 years and then yeah, carry out my model. So let me call another model. Let me call it a linear model. And let me call this actually LM3. And life expectancy, total expenditure plus schooling. So now I have, I have removed the correlated variables. Just to make it readable, you can just change some of the way it's aligned. And then once you have that, you can run it. By the way, you can also run linear regression model using GLM, using generalized linear model. The only thing you need to define is you need to define the method into Gaussian. So once you write the Gaussian, so that will be exactly the same. The output will be the same. Normally with GLM, you can define your GLM has a lot of modeling options. You can run linear model, you can run logistic regression model or Poisson's negative binomial, and so on and so forth. There are many different kinds of models in GLM. But the usual way of doing linear model, people prefer to use LM instead of GLM. But you can use LM also. Now again, let me call that sum function from the GTools that I was showing previously. So let me just LM3 and let me add my confidence intervals, and let me also add this rounding digits into 3, and let me again display my variance inflation factors. Now it should be less. So now you see my variance inflation factors, there is one which seems to be still high, but otherwise, yeah, it's kind of okay. But you can also have a look. I think alcohol, do I have smoking? So alcohol with, so it should be alcohol with schooling. Interesting. So people who who are at school, who have a high number of schooling, they also have high, yeah, drinking habits. That might be, but I think it's okay. I can just ignore this one because it's not very bigger than 2. But it's usually if the variance inflation value, if this value is larger than 2, then it might be a good idea to remove some of values. I think it's 5 or 2. Yeah, that's tolerable. If 2 is tolerable, it's okay. Now what you can do is, let's say we want to visualize these values. I think for that you can also use Broom package, library, Broom, and let me just use, call it model output, and then let me use tidy function, then LM3. Then I can run out confidence intervals. Then I can use tidy again, tidy function, then LM3, then conf int equals conf int equals 2. This is not how it should be. Conf int. This is how it should be. Yeah. Now it should work. No. Equals 2. All right. Okay, LM33. It's not LM33. It's rather LM3. Now, what I want is let me have a look. Out confidence. This is confidence interval. So I have all my confidence intervals for each variable. And this conf low, conf high. Let me have a look again. What does this output looks like? Yeah, this shows the estimate, the statistic, and the p-value, and the variables, and the terms. I mean the variables or the terms. Now what I can do is I can use this library, Forest Manager. That's actually something that I can Forest Manager. Then once I have that, let me just call this linear model out, and let me round this, round df. Let me use the round df function from Forest Manager, and then outconf. What is this outconf? Because I want to use it, to put it in 2 significant digits equals 2. Now it's already there. Let me run this and have a look how it looks like. So now I put them all in 2 significant digits. Okay, the next thing what I need is I can remove the intercept. Maybe let me remove the intercept. Might not be needed, but you can keep it. I want to remove it. So what I can do is to remove it. I can simply take this superscript method, and then because I'm using the row, because this is the intercept, so you can put it in the first one, and then the rest of it will remain the same. Now once you have that, what you can do is, because we want to plot these guys, these numbers in a plot, in forest plot. So for that, now I can use Gplot. My data is this LM model out. So I can do this LM model. Then once I have that, I can do this AES X term. That's because it's showing the term. This is my term. So then the next thing is estimate. No, the term. I have to reorder it so that it will be more elegant. So the plots will need to be arranged like in a forest plot, or the confidence intervals should be arranged in a way. I mean, we can do it without arranging them, and then we can arrange them later on. Let's say my y variable is estimate, because that's what I want. This is my estimate, and then I can use this function from Gplot to geom error bar. For that, I will need to give it some static definitions. The y-min should be my confidence intervals, the lower limit, conf low. So that's what I need for the y-limit, conf low, and for the y-max, y-max should be conf high, and then I will need to add some more arguments, and let me put it, the width should be, let me put it like 0.1, no, 0.2 is better, and the size to be 1. Now once you have that, let me put the position, let me just give it a Doge, it's a one Gplot to argument, you can have a look, and maybe I can define the color. The color could be, I don't know, let's say blue or dark green, depending on your color choice, dark green. And then once you define that, now you have to give it a horizontal line. So for that, geom h line, we have to use geom h line. Geom h line. For that geom h line, what we need is y-intercept. So the y-intercept is 0, and the color, let me make it, because that's a null point that I will have to use, the null point for my regression equation. So color would be red. Let me put it as red because that's a null point, which is the estimate is 0 or not significant. There's non-significant point, so that's a null point. And then let me give it a size of whatever your choice, let's say 1. And then I need to add another geom function, that's geom point. And once I do that, so this is geom h line, so things will be written, the estimates will be on the y-axis and the term would be on the x-axis, but it's rather more elegant if you flip this. So then let me just show you. Doge is not more. Okay, no, I need to do this. I'm using this Doge coin. This is not Dogecoin, it's the Doge position Doge. So it seems we have made somewhere we have made an error. No, it is conf high and conf low. So now you see it looks like this, but this is not really really nice. So what you can do is I can add the chord flip function, so then I can flip it. So to chord flip it should be here, and run it, so it will be flipped. So now we have our our terms and the coefficients. Still something's wrong here. It's plotting it, it's putting it, but it's because it's narrow, I would say. It's a very narrow confidence interval. So we may do something better. So we may reorder these variables so that they can be arranged nicely. So the way we reorder this is we can use this reorder function. So I'm sure you know how to reorder bar graph, or or some graph based on based on the term, based on its values. So I can reorder the term value by estimate. So I can add the estimate function here. I mean the estimate value. So I can reorder estimate. Actually, yeah, it's already detecting it. So that means I'm reordering the term by its value. Its value is the estimate. So now these values will be arranged. This one will appear at the very bottom, and the other values, let's say, yeah, it will be rearranged depending on how values. So the bigger the negative coefficient, the smaller one here will appear here, and then the other one, this guy will appear somewhere on top. So let me run this. Yeah, so they are arranged in this way. I mean, this is not the end of your goal. maybe you can add, like, you can label, you can change the labels. I think that's pretty easy to do. Yeah, in Gplot. But theme, let's say if I want to avoid this, I can simply add theme void, let's say, if I don't want this. So you can appear like this, but this is not what I need. Theme gray, let's say, should be fine. Gray is a classic one. Okay. Anyway, there are many themes that you can play with. Now I have this, and I think the next way of doing it will be using another package. I think I will do that in another tutorial. I mean, spending more time in one tutorial might be a little bit boring, but I will have part 2, part 3 for this, because there is a more elegant way of presenting this regression plot. So keep in touch and wait me for the next one. I will continue plotting it so that until you find the right plotting function. But until then, I advise you to look at my website here. So I have it's one of the mostly read blog posts. So I decided to make a video. That's why I decided to make a video of it. So other people who were really looking for this blog post might get a better idea if I do a video about this plot. So it's really everything is explained. This is one of, I don't know, I have written some blog posts, but this blog was the mostly viewed blog. I get 500, 600 views per week. So it seems it's really, many people are. I'm glad that many people are using it. So I will make another videos, part of these videos, so that we can plot some part of it. I think the nicest part would be using this Gplot. Yeah, but I will show you the other ways of plotting this regression equation. I mean the regression coefficients. Thank you for today. Enjoy your data science, and please make sure to subscribe, because that will encourage me and you will be kept in touch with me. Thanks.